P is product of mass and velocity. So whatever the velocity of the object will be at that instant, that will be multiplied with the mass of the object. Okay. If mass is variable, then also momentum will change. If velocity is variable, then also momentum will change. If both are variable, both are changing, naturally linear momentum will change. The direction of momentum is same as the velocity. These all we have done in case of when we have discussed Newton's second law. Now, to understand this law of conservation of linear momentum, first we will see what is the meaning of a closed system and what is the meaning of internal and external force. So, closed system means suppose there is a room and it is, or in the classroom, the door and windows are closed. So that is closed system. So whatever students are present inside, they are the part of that system only. Now suppose one student applies force on another student, pushes the other student, or third is pushing fourth student, or anyhow any force is applied. This we will treat as internal force. Like there is force of attraction between the particles of the system. Law of conservation, gravitational law says there is force of attraction between any two objects of the universe. So whatever force of attraction between the particles of the system will be, that is internal force. If anyone or any other force is applied whose source is outside, then we will say it is external force. For example, suppose there is three particles are there. Now this is the closed system. Three particles are there. Now the force applied by first on second, that is there is force of attraction, and as we know force is always produced in pair. No, third law says, means third law, according to third law we say the force is always first on second. The second will experience force in this direction. This we call F21. That is force experienced by 2 due to 1. Now, the reaction will act here. F12 will act this place. This is the one pair. Similarly, force applied by this F23 will be in this direction, whereas F32 is in this direction. One and three, F13 in this direction, whereas F31 is in this direction. So these all are internal force. Now the force applied by Earth on this system. Earth is also attracting these all three, or the whole system. That will be treated as external force now, because Earth is not in our within this system. Earth is outside. Or if you start pushing this box, which contains three objects, three particles, you start pushing this box, then force applied by you will be the external force. Is it clear what is the meaning of external force and what is the meaning of internal force? So just to see, if we find the resultant of all these internal force, this force and this force equal and opposite. Each force will be how much? The force of attraction is G m1 m2 over r square. So whatever force is applied by this object on this, same force is applied by this object on this. So these two will cancel each other. These two will cancel each other. These two will cancel each other. That means the net internal force is always zero. So due to this internal force, there will be no change in the momentum. Because we know this force is how much? Force is rate of change of momentum. If force is zero, momentum, there will be no change in the momentum. So as the resultant of all the internal force is zero, always, so resultant of all the internal force will be zero. Therefore, there will be no change in the linear momentum of the system or closed system. Due to internal force. So this result frequently we use. So as the resultant of all the forces is zero, there will be no change in linear momentum. Linear momentum may be there. If suppose this box was moving, then it will continue to move with same velocity, provided no external force is applied. So due to this internal force, there will be no change in the linear momentum of the system. Individual particles' momentum may change. If this experience large force of attraction, it may come to this side. But as a whole of the system, there will be no change in linear momentum. This is very important result, and we are frequently using this. Now, this force is rate of change of linear momentum. That means this delta P or change in momentum will be how much? This resultant of force into delta T. This resultant may be external force plus internal force, all the resultant into delta T. So this we are saying resultant of all, whole internal external force, whole internal force. Now you know due to internal force there is no change in linear momentum. So this change in linear momentum will be only due to external force. Since there is no change in linear momentum due to internal force. So if any system, if there is change in linear momentum, that means there must be an external force. Without external force, linear momentum of the system can't be changed. If a ball is rolling on the ground, without force, its velocity will not change. Without external force, its velocity will not change. So suppose ball is rolling, it is changing the velocity due to friction. So that friction is outside the ball, source is outside the ball. So this is external force. If now if anyone kicks the ball, that is the external force. If someone catches the ball, that is also external force. So in that case only there will be change in linear momentum. So how much change in linear momentum will be, that will depend on what is the external force and for how long it is acting. This sometimes we call impulse also. Now, if external force is also zero, what will be? There will be no change in the linear momentum. And that is law of conservation of linear momentum. If this external force becomes zero, what will be? Delta P will be zero. That means P is constant. Linear momentum of the object will be constant. And this statement is the law of conservation of linear momentum. So what will be the law of conservation of linear momentum? If no external force is applied on the system, then its linear momentum will be conserved. So that is the law of conservation of linear momentum. So we say if no external force is applied on a system, then the linear momentum of the system. So whatever the linear momentum of the system will be, initial or final, must be same. Linear momentum of individual particle of system may change, but as a whole, there will be no change in the linear momentum. So linear momentum of individual particle of the system may change. What? Resultant of linear momentum of all the particles will remain constant. Or there will be no change in the linear momentum of the system. System means, so whatever the linear momentum of all the particles may be, that is this P1 plus P2 plus P3, whatever the individual particles may be, this one will be always constant. Whatever the initial will be, whatever the final will be, it will remain same. Because there are two balls are there, or any object of any shape it may be. This is of mass m1, it is moving with velocity u1 in this direction. This is mass m2, it is also moving with same velocity, different velocity, u2 in the same direction. We may take opposite direction also, but for our convenience, if this direction we are taking positive, then these all will come positive only. Now this u1 is more than u2. As they are moving in same line, so what will be after covering some distance, they will collide with each other. And then we are saying, okay, these all are moving after collision. It is moving with velocity v1 and this is velocity v2. In this case, this v2 will be more than v1. Then only they will be separated. Till velocity of this one is more, they will not be separated. They will remain in contact. They will be separated only when the velocity of this become more than this, more than first one. Understood? Yes? No response. Still same condition. Okay. So suppose this is moving in this direction. After some time it collides with this and then they are separated. During this collision, during the time of contact, when these two are in contact, what will be? This will apply force on this one. So it will experience force in this direction. Suppose this we are saying F21. And this will experience force in this direction, F12. The force experienced by first, when they will come in contact, this ball will try to push this. Whereas this will oppose. Always action and reaction is produced. So by what force this one is applying, whatever force is applied by first ball on the second, same force will be applied by second on first, but in opposite direction. So what does it mean? This F21 is minus of F12. Magnitude will be same and direction will be opposite. Now let these two balls remain in contact for time delta t. So whatever change in momentum will take place, that will be during this time only. Or you can find the force directly. Force will be rate of change of momentum. So force experienced by second due to first. So this is the mass m2, velocity that is v2 minus u2 by delta t. Because during this time of contact only its velocity has changed from u2 to v2. Whereas during same time, velocity of this first ball has changed from u1 to v1. So it is with negative sign m1 v1 minus u1 by delta t. So delta t cancel. So what we get? m2 v2 minus m2 u2 will be equal to minus of m1 v1 plus m1 u1. Now we are taking this one this side. m2 v2 plus m1 v1 is equal to m2 u2 plus m1 u1. This we have taken this side, this one we have taken this side. So what is this? This is the momentum of these two balls. If these two you are considering a system, then momentum of the system before collision and momentum of the system after collision, it must be same according to the law of conservation of linear momentum, and that we are getting here. This is momentum of the system after collision. This is momentum of the system before collision. So these two are same. So momentum of system after collision is equal to momentum of system before collision. And that is the law of conservation of linear momentum. So momentum of system after collision and momentum of system before collision will be same. And this is said by law of conservation of linear momentum. This we have proved by this one, by using Newton's third law. Because during collision, when they are in contact, this will apply force on the second one, second will apply force on the first one, and force will always be equal and opposite. One we call action, other we call reaction. So this is about law of conservation of linear momentum. Now, how we'll use this to solve different problems? That is the main part. So according to this, we got momentum of individual particle may change. See, momentum of first particle. Earlier it was m1 u1. Afterwards it became m1 v1. So momentum of individual particle will change, but there will be no change in the momentum if we are not applying any external force. So here, as we have considered these two as closed system, so this is our system. So whatever force is applied by this on this one, and whatever force is applied by second on first, that is the part of the system only. So that is treated as internal force. And we know due to internal force there will be No change in linear momentum. From outside, no one is applying force. Only this particle is applying force on this particle. This particle is applying force on this particle.